Hey everyone, I want to address the answers that you gave me for the problem of the croquette thing. And well, this is it. Question number one: what is a spheroid? And this one is a sample of the answers that you gave me: a quadratic surface, a rotated ellipse, uh, ellipsoid, semi-diameter, circular symmetry. That's all good, that's correct. But my question is, do you understand that? Do you understand what all of that means? What all of the words mean? Maybe, maybe not, probably not. I understand it, and you could get to understand it too, but just written like that, I get the feeling that you didn't understand a single thing. And for this question, this one, the answer comes straight up from the Wikipedia, but if you kept on reading, in the paragraph number 4, I guess, on the introduction, it says the word spheroid originally meant approximately spherical body. That's something that everybody can understand. So spheroid is basically just a sphere, but not quite. And also in the introduction, you see a picture of what a spheroid looks like. And it has the two words that come in the next question, ovulate and prolate. And you can see the difference there, and you can see that it's, well, a sphere, but not quite. It's kind of a squeezed sphere, and that would have been a better answer. What's a sphere? A squeezed sphere. Just like that. Simple as that. Question number 2. What is the difference between a prolate and an ovulate spheroid? And again, straight up from the Wikipedia, this was your answer. An oblate, the first one is for the oblate spheroid, and the second one is for the prolate spheroid. And yet again, it would have been better if you just put that along with a picture, because it's clear. It's much more clear with that picture to kind of just right away spot the difference between an oblate and a prolate spheroid. Question number 3. What is the formula for the surface area of both figures? And again, the Wikipedia page gives you this, and this is pretty much what everybody wrote as an answer. But again, do you really understand all of that? Do you understand what is arctangent, hyperbolic arctangent actually, arcsine, what is the C, what is the E, what are all of these parameters? And again, if you kept on reading, or if you had read all the document, the Wikipedia page, you would have realized that it's way better to use these ones, because the first formula for the oblate one contains things that you know. Everything there you know. You know logarithms. And also you have to define me what the things are. In the Wikipedia page you see what's the E, what's the definition of E. And again, you have A, you have C, but you have a picture, you have a drawing of what those parameters are measuring, what they are. So you have to give me something like this, the formulas, along with what is the meaning of all the parameters involved. Question number 4, what's the volume of a spheroid? Pretty much everybody answered this, which is correct. But again, if you didn't put a picture, then I'm kind of lost of what A and C mean. And for the open-ended task, after answering these questions, obtain the surface to volume ratio and compare it to the other forms that I already had compared in the other document, and tell me which one's better, how much better. For this one, the first thing is this kind of a reading comprehension question, and the first thing you notice is this. This is the first instruction: obtain the surface to volume ratio for the oblate spheroid. That is just putting the surface formula and divide it by the volume formula. So you know what to do. Now, this is not as easy as it seems, because you just don't put the surface formula over the volume formula. You have to simplify it. That's the second thing. Simplify this expression to actually obtain something that you can compare to the other ones. This is hard, but nobody asked me anything on Monday, and nobody asked me almost anything on Tuesday either. And on Tuesday or Monday afternoon, I guess, I gave you this. I gave you the formula already. I gave you the worked out formula, so this is it. And this is something that I put on a document, but again, nobody asked what was the K. What's the K? It's the squeeze factor, and it's going to become clear what that means, what that factor does. Um, with an applet that I also did and I also gave you, I put it in the drive folder, a GeoGebra thing. So the next question, for now, this will suffice. The next question is it better than the sphere? How much better? And in the GeoGebra applet, you can see that the K factor is basically just the squeeze factor. In red, you see the sphere, and in blue, you see the spheroids, the oblate spheroids. And you see that they change shape. They kind of get flatter if K decreases, and if K is big, they become more round, closer in shape to the sphere. So that's it. And I would say also that even though mathematically you can still have a spheroid for very small values of K, for values below 0.5, you don't really have a croquette anymore. So I will limit my analysis to values of the squeeze factor from 0.5 to, let's say, 0.85 or 0.9, something like that. And remember that the equation on the top is the one that we're going to be comparing to the other ones. And if you do that, you just needed to kind of graph all this stuff in Desmos. And if you do, for instance, this one is the comparison between the equations for a sphere, the surface to volume ratio of the sphere, the surface to volume ratio of the spheroid, and the surface to volume ratio of the cylinder for a squeeze factor of 0.5. And you see that for 0.5, this one, this shape over here, the spheroid is way better than the sphere, and it's also better than the cylinder. For a squeeze factor of 0.84, a big one, you have that it already is closer, much closer to the sphere, and you kind of just play with this slider and see where it crosses the cylinder and how it decreases until it gets pretty close to the sphere. And you had to kind of give me a description of all that. When does it happen? For which values of K does that happen? Which one then you believe it's a better croquette based on what the shape is, what the area is, if it is better or not. You have to explain, you have to elaborate on that. And after all of this, is this a valid question? What shape of croquette is better? Well, it depends on how you define valid, but if you actually, again, if you go to the Wikipedia of croquette, straight up you can see these examples over there, in which you see the ones that we call cylinder shaped, or these ones, the ones that we are calling cylinder with caps, or maybe closer to a spheroid shape. So yeah, I think that this is a valid question to ask what shape of croquette is better. By better, I mean which one is crunchier. Totally valid question, and one that it's worth exploring and easy to explore using math. So for the next questions like this, the open-ended questions, try to make a better analysis, much like this. If you don't understand something, just don't put the answer. Try to tell me why, try to explain me why you're putting as an answer what you're putting as an answer. Okay, so that's it.